Hey everybody, Mr. Moriarty here. We are going to go through the first study guide for our first test, which will be on Monday. I'm going to go through this as quickly as I can so you can get to the second study guide today. So I'm going to have a calculator handy to do all of my calculations. And I'm going to try to talk through this efficiently, but also trying to help you guys. So hopefully you're using your notes or your um, foldable. But what we're going to do first is combine like terms. So the like terms in this first problem are the 9.3x and the 8.8. 9.3 minus 8.8 gets me 0.5x minus the 1.4 equals the 23.45. Okay. From there, we have our variables on one side. We will add the 1.4 to move it across the equal sign. It's going to leave me with 0.5x equals whatever 23.45 plus 1.4 is. So that's 24.85. Right? The final step on this particular problem is to divide both sides by 0.5. Okay. X equals 49.7. I know I emphasized no decimals in here, but since the problem was already set up as a decimal, I just went ahead and used it. All right. On to the next one. First step is going to be distribute. All right. So I'm going to bring my 50 down. Negative 10 comes down. 3 times x is 3x. 3 times negative 8 is a negative 24. Now we combine like terms. It's going to be the negative 10 minus 24. You're not going to add, like I see some of you guys do, like plus 10, plus 10. Don't do that. Don't do that. Not when they're on the same side. Okay, you just use what the signs are in front of them. So we take a negative 10 minus 24 to get me negative 34. So I'm still bringing that 50 down. This gets me a negative 34 plus the 3x. All right. From here, I'm going to now add 34 to get my constants on one side. 50 plus 34 is going to be 84. That's going to equal oh my, this is not what I meant to do. 84 equals 3x. And then the last step is to divide both sides by 3. So 84 divided by 3 is 28 is what I got. So the solution to this problem is going to be x is equal to 28. Okay? Number 3. All right? I'm going to start by doing the distribution. Gives me 18x plus 27 equals 12x plus 15. Get your variable terms on one side. After that, because there's no combining like terms, so I'm going to subtract the 12x on both sides. Minus 12x, minus 12x, 18 minus 12 gets me a 6. That should be an x. So 6x plus 27 equals 15. And I'm going to subtract the 27 on both sides. I'm going to be honest, my finger is sticking really, really bad to this iPad because of how humid it is outside. So that's why things are a little messy. Okay. So I subtracted the 27 from both sides and then just divide by the coefficient on both sides to get x is equal to negative All right, there we go. That's 3. Number 4, start by doing the distribution. I know it's a fraction, but it's still done the same way. 1/3 times x is 1/3 x. 1/3 times 9 is going to be 3. So just by doing the distribution, we get rid of that fraction. We're going to subtract 3 from both sides. Be left with 1/3 x equals 12, 11, 10, 9. Now, you guys might say at this point the solution is going to be 3. It's not. You can either multiply by the reciprocal of 3 over 1, or what I've seen a lot of you guys do, and I might do this just because maybe it'll help some of you that still don't really like the fraction stuff. Divide both sides by the 1/3 coefficient. That's what I'm going to do on this. Because when you do that and you put it into a calculator, you'll actually see that the solution is 27, not 3. Okay? Then we get to 5. 5 is a question type that we've not really seen before. I'm going to do this kind of quickly. Some of you will be confused, and that's okay because we can talk about this on Monday before the test. But here's what we're going to do. The first thing that we're going to do is I'm going to multiply everything by the denominator of 2. Now, when I say everything, I mean everything on both sides. Okay? What's going to happen here is this 2 will cancel with the denominator, and your numerator of 4x minus 6 comes straight down. Okay? I can explain that on Monday, but that's what's happening. Since we're multiplying everything on both sides by the 2, on the right side, we have to distribute that 2. So 2 times 9 is 18. 2 times a negative 1 is negative 2x. Okay, that was the hard part. Let's finish this one up. I'm going to add 2x on both sides to get my variable terms on one side. It's going to be 6x minus 6 equals 18. I'm going to add 6 on both sides. 6x equals 18 and 6. My brain's not working. 24. Divide by 6. And we get x is equal to 4. Okay, that's a complicated one because of that first step. Like I said, I can help explain that a little bit on Monday. The last one that we have, okay, it's just difficult because it's fractions. That's it. Get your variable terms on one side. 2/5, I think 1/3 is larger than 2/5, so I'm actually going to subtract 2/5 here. I could be wrong. And if I am, that's fine. We'll just go with it anyway. Notice that that is a negative 13, so that will come down. 1/3 in my calculator, 1/3 minus 2/5 gets me a negative 1/15. So I guess I was wrong. Oh well. Negative 1/15 x. And then I still have a 1/15 over here. Now those are not like terms. They just have the same number. There's no like terms here that we can combine. But what we will do is we will subtract the 1/15 minus 1/15 in my calculator. Negative 13 minus 1 over 15. Yikes. Oof. Okay, so this is going to be it's a nasty one. Negative 196/15. And that's going to equal negative 1/15 x. Whew. So what you can do here is either multiply by the reciprocal, but again, what I'm going to do is what I did on that earlier fraction. I'm going to divide by the coefficient. So I'm going to divide both sides by that negative 1/15. So this divided by negative 1 over 15 Yeah, that's going to work out pretty nice, actually. So we get 196 for x. All right, so there we go. So those are going to be the ones that are most time consuming because of the work that is in them. All right, on to the rest. Number 7, fill in an expression to create an equation with infinitely many solutions. Remember, this is going to be the same variable term or variable coefficient. And the same constant. Constant is the number without a variable. So if we want infinitely many solutions, legitimately, I'm just going to copy the same thing over. Keep it simple. Keep it simple. Okay. All right. Determine if the given equation has, we want no solutions. So that is going to be the same variable coefficient, but it's going to be different constants. All right. Different constants. So variable coefficient is the same. Constant is not. So this is true if the equation has no solution. So this is going to be a false. I'm just going to write F. It's less writing for me. Okay. Next one. Variable coefficient is a negative 2x on both sides. The constants, though, are different. So this would be true. This would get you a no solution. Okay. The next one we need to simplify a little bit. So 6 times 3x and 6 times 3, so this is 18x plus 18 plus 7 equals the 15x plus 14. 18 plus 7. Oh, actually, this isn't even really going to matter at this point because our variable terms are not the same. So this will actually just be a one solution one, which would make this one false as well. Next one. 1/2 of 6x is 3x. 1/2 of 12 is 6. Again, this is going to be, yeah, my fingers are just very, very sticky on this iPad right now. It's terrible. But yeah, so this is going to be a one solution as well. So this is also false. It is not a no solution. 3 minus x equals 5x minus 6x. That gets me a negative x plus 2. That'll work. Same variable coefficient, different constants. So this one would be true. Okay? So there we go. All right. Next one. Will the expression create an equation with one solution? All you have to do on here is make sure you have different. It's getting in my way. E-R-E-N-T. Different variable coefficients. Okay? Different variable coefficients. C-O-E-F-F-I-C-I-E-N-T. I don't know if I spelled that right. Oh, well. So it doesn't really matter about the constants, but we want to make sure that when we simplify these down, we don't have a 13x. We do not want to have a 13x when we simplify these down. So negative 2x, that is not 13x. So this is yes. Okay. This is a 13x right here. So that will not result in one solution. That will be a special case, either a no solution or an infinitely many solutions. So that's a no. Negative 15x plus 2x is a negative 13x minus 4. Negative 13 is not the same as 13, so technically, yes. this would result in a 1 solution, okay? And then half of 26x is 13x, half of negative 4 is negative 2, but that 13x, we don't want that, so that's going to be a no. It's a no for me, dog. All right? Okay. Next one, solve the equation. 7x plus 5 equals 5 plus 7x. Now, I see the way that this is already set up. This is going to be easy for us, okay? So since those variable coefficients are the same, it's either going to be a no solution or infinitely many solutions, okay? This is a 5 and this is a 5, so that means the constants are the same as well. So we've got same constant, same variable. This is going to be C, infinitely many because of that reason. Number 11, I'm just going to tell you how to do number 11. Since y's are the same like this, so we have y is equal to y, which is true. I mean, it's just any number equal to itself. That's true. But since that's the case, we're going to set this up like this. We're going to set their their right sides up equal to each other. So that'd be an 8 plus a 2x. From here, I'm going to subtract 2x. 4.5 minus 2x, or 4.5x minus 2x gives me 2.5x. Minus 7 equals the 8, because those cancel. I'm going to add 7, add 7. I'll have to go up over here. 2.5x. Man, this is so hard to write. Plus 5. That's not it. Equals 15. 8 and 7 is 15. Okay, so we've got that. And then divide both sides by 2.5. Okay, so 15 divided by 2.5, 6. X is 6. Okay. On this last one, I'm just going to kind of point this out and talk, just because I don't want to write anymore, because it's actually starting to hurt my finger, because it's so hard to write on this. So Debbie and Cindy solved the same equation. One of them solved the equation incorrectly. Identify which student made the error and explain the mistake. So the first thing that we have is combining like terms. So let's see if they did it right. Negative 4 plus 12x, that is not negative 16. Let's see if Cindy did it right. Negative 4x plus 12x, that should be an 8x. Cindy did it right. So Cindy is right, Debbie is wrong, and that's going to be it for this, okay? If you have questions on today's or this study guide, or the one that you're going to be getting today, save them for Monday, and we will answer them then. I will see you next week.